Artificial intelligence is often presented as objective and data-driven, but that assumption is dangerously flawed.
The answer to that question reveals a fundamental weakness in many AI systems, a weakness that carries significant, real-world consequences.
The problem really starts with something called edge cases. An edge case is simply a situation an AI wasn't explicitly trained to handle. These are the outliers, the anomalies that don't show up very often in the data the system learned from. Think about an autonomous car seeing a new type of temporary construction sign, or a medical AI trying to diagnose a rare condition it's only seen a handful of times. It could even be a fraud detection system flagging a perfectly normal but atypical purchase. While each of these events might be rare on its own, their collective impact is enormous. In fact, a reported 80% of AI failures in live environments happen because of these exact kinds of edge cases. This is what's known as the long tail problem. An AI might know a few common scenarios extremely well, but there's a nearly infinite number of rare scenarios that stretch out like a long tail. It's impossible to train a model for every single one of them.
So why do AI models struggle so much with these unfamiliar situations? The technical reason comes down to a concept called overfitting.
Overfitting is what happens when a model learns its training data too well. Instead of learning the general patterns, it essentially memorizes the specific examples it's seen, including all of the random noise and unimportant details. It's really the difference between memorizing and truly understanding. An overfitted model is like a student who memorizes the answers for a single test. They might get a perfect score, but give them a new test on the same subject, and they'll fail. They can't generalize their knowledge. This makes an overfitted model incredibly brittle. It performs perfectly in the clean, controlled environment of its training data, but it breaks the moment it encounters the messy, unpredictable reality of the real world. But this technical failure to generalize isn't just a technical problem. It has a critical and often very harmful social consequence. You see, the data that gets left out, the rare scenarios that become these edge cases, very often correspond to people from minority and underrepresented groups. If the training data doesn't reflect everyone, the model's failures won't affect everyone equally. And this is how a technical flaw like overfitting becomes algorithmic bias. These aren't just random, one-off errors. It's the system producing systematically unfair outcomes, over and over again, for specific groups of people. A well-known 2018 study, for instance, found that some commercial facial recognition systems had error rates as high as 35% when identifying darker-skinned women. For lighter-skinned men, that same error rate was less than 1%. The model simply hadn't seen enough diverse faces. The consequences here go beyond the ethical concerns. They create enormous business risks. We're talking about safety issues and physical harm, significant financial losses, damage to a brand's reputation, and even legal action for discrimination. So if this long tail of edge cases is practically infinite, how do we build better, more reliable AI systems? The goal has to shift. It can't be about eliminating every possible error. That's just not possible. Instead, it's about building resilient systems that anticipate these failures and can manage uncertainty effectively. This approach relies on three core strategies. First, deliberately diversifying the training data to include those underrepresented groups. Second, implementing a human-in-the-loop, where the AI can send low-confidence predictions to a human expert. And third, continuously monitoring the system's performance to log new edge cases and feed them back into retraining. Because in the end, human judgment remains the most critical component. Humans are still needed to handle ambiguity, to override an unsafe decision, and, most importantly, to ensure there is accountability. So building trustworthy AI isn't really a quest for perfection. It's about designing systems that understand their own limitations. The fundamental question isn't just about making AI smarter. It's about how we build AI that knows when it isn't smart enough.